All right, to start this one off, I want you to try example 2. Follow the same steps that we did in example 1. Find where the derivative is 0 and find where the derivative doesn't exist. Use the sign charts. I'm going to just put the answers up. I want you to see if you can answer all of these. I'll show the work in just a moment. All right, so I used the product rule. This is not a chain rule, it's a product rule. First times derivative of second plus second times derivative of first. I factored out an e to the x, and then I had to figure out where does this function, I factored this, where does this equal 0? You could have used your calculator to graph it as well. E to the x is never going to equal 0. It has an asymptote there. This one's going to equal 0 at -3 and this one at 1. So I have two critical points at -3 and 1. Now once again, I have no endpoints. I don't have a closed interval, so I don't have any extreme, absolute extreme values guaranteed to me. So when I did my sign chart, we get a positive, a negative, and a positive. That means that the original function went from increasing to decreasing back to increasing. And in fact, it might help you to draw that in. Decreasing back to increasing. So that means we've got a max happening here and we've got a min, I missed that a little bit there, happening here. I can write myself a note that f of x is increasing when x was less than -3 and greater than 1, and f of x was decreasing between -3 and 1. And then when I find the maxima and the minima, I know that the max happens at -3, the min was at 1, and when I plug those values in, you can do them on your calculator as well, but you don't have to.